Hello, this is Chitran Saxena from Just Tutors. Today we are going to learn about light and refraction. So today's objectives are a refraction of lights, a refractive index, lens, different terms related to lens. Let's move ahead and start with a refraction of light. So basically, the change in direction or bending of light when it passes from one medium to another obliquely is called refraction. As you can see here, that like this is a piece of glass, light is entering from this side, it bends here, and then again while going outside, it bends again. This is incident ray, this is refracted ray, this is angle of refraction, this is angle of incidence. So we can say refraction takes place at boundary of two media. The amount of refraction of light depends on the difference in the speed of light in the both medias. There are some terms related to refraction of light. So the very first is emergent ray. Emergent ray is the ray which comes out from glass after total refraction. This is emergent ray or refracted ray. Angle of emergence. The angle between normal and emergent ray is known as angle of emergence. One thing to be noted there, in refraction of light, the angle of incidence is not necessary to be equal to the angle of refraction as in reflection of light. Now, optically rarer and denser mediums. What are the difference between rare and denser medium? They are basically medium in which light travels faster, they are optically rarer, and in mediums which light travels less speed, they are denser mediums. So we can say there are two rules which give the direction of bending of a ray light when it goes from one medium to another. When a ray goes from rarer to denser medium, it bends towards a normal. As you can see, it is going, if light will go from less dense medium, it means rarer, and it is dense. So if light is going from rare to denser, it will bend towards normal like this. So it will like go like this. And opposite, if light is going from denser to rarer medium, so it will go like this. As you can see, it will make a bigger angle from the normal. There are some effects of refraction of light. The very first, we can see an object placed underwater appears to be raised. As you can see here, that this coin is placed at the bottom, but when you'll see from the outside, it will look that it is at some height. A pool of water appears to be less deep than it actually is. A pool of water, the star appears to twinkle on a clear night. A stick held tilted and partially immersed in water appears to bend at the water level. When ray goes from denser to rarer medium, it moves away from normal. Now, a new term, refractive index. It is the ratio of sine of angle of incidence to the sine of angle of refraction. It always remains constant for a given pair of media, and this constant is called a refractive index. So this is kind of ratio with between sine of angle of incidence and sine of angle of refraction, and it is always a constant. We can also write it like sine I over sine I equals n, and n is a constant used for refractive index. Refractive index is also like a ratio of speeds of light in two media is also said to be refractive index. As let's say speed of light in medium 1 over speed of light in medium 2 is equal to 1 and 2. We write it like this. The refractive index of a medium indicates the light bending ability of that medium. So speed of light can be written as v, so it is v1 over v2 equals to 1 and 2. A reflection of light by spherical mirrors. How does spherical lenses, sorry, it is lenses not mirrors, show refraction? A lens is made by bounding two pieces of glass which are part of hollow sphere. As we have spherical mirrors like this, if we cut apart from a hollow sphere and not single, just two parts, and merge them or join them like this. So they will give two type of lenses. One is convex and one is concave. If you do like this or like this, as you can see here, this is convex lens, this is concave lens. A lens which is a thin at edges and thick at centers is convex. A lens which is thick at edges and thin at center is concave. Now there are some terms related to these lenses. At the very center, as in mirrors we have pole, here the center of this is known as optical center and represented by small c. Principal axis, again an imaginary line which passes through the optical center. Principal focus, a point at which light rays parallel to principal axis converges after passing through lens. This is for convex lens. Focal length, distance between optical center and principal focus of lens. So you can see if we have a convex lens and a parallel beam of light is coming entering into it, so it will converge to the point, and this point is known as focal length, and the distance sorry, not focal length, this is focal point, and the distance between the optical center and the focal point is focal length. Convex lens is also known as converging lens, and for principal focus we can also say it is also known as focal point. The principal focus, a lens has two real foci which are at two equal distances on the either side of lens. As we had, this is a lens and light can enter from both the sides, so we can also have a principal focus at this end as well on the same distance. The focal length from here to here will also be equal to here. For concave lens, principal focus, a point at which light rays parallel to principal axis appears to diverge after passing through a lens, and it is, we can say for this that a concave lens has virtual focus. As you can see in this picture, focal length, distance between optical center and the principal focus of lens. Now there are some questions for your practice. Try them, pause the video, and then check your answers on the next slide. These are your answers. I hope your answers are correct. That's all for this video. For more videos, you could log on to justtutors.com. Thank you.